Well, since I got this amp on the bench, I was just gonna use it to do a demo on, well, not actually a demo, but to show soft start or step start in this amp here. Basically, the power transformer is underneath this, and then this board, high voltage board here, sits on top. And with the high voltage transformer, the low voltage coming in, the low voltage taps going into the power transformer actually go to these two relays here, and they go through, each leg goes through these two power resistors right there. And what those resistors do is, that's your soft start or step start. When you first turn on the amp, these relays are not engaged. It takes them about half a second to click in. And before these relays kick in, those two resistors are in each resistor is in one leg of the low voltage winding coming in, so they drop the voltage coming into the power transformer a lot. And if you drop the voltage coming in, you're going to drop the voltage coming out. And so that low voltage comes out and charges the capacitor bank, which is actually under this high voltage board here. Originally it had a oil field capacitor, but that went bad, so it was replaced with a electrolytic bank similar to this one here, except that one, since this amp runs on I believe 4 kilovolts, it actually had 10 of these caps similar to this in series, instead of this one having 8. But it was similar to that, which is under here, but you can't really get a good picture or see it up under there. So anyway, for that half a second, that power coming into the transformer is going through these, and until those caps get charged, because a dead capacitor bank like that looks like a dead short when you first turn it on. If you ever had even a big sweep tube amp or CB amp, and you got it on 110 and you turn it on and the lights dim for a second when you first turn it on, that's these capacitors charging. When they're dead, they look like a dead short, and then once they get a charge in them, they are right. Similar to a car battery. You ever try to jump or put a charge on a dead battery? When it's totally dead, you get a spark, and as it gets that charge going, it's going to pull less and less amps. Well, capacitors work the same way. It's just a lot, much quicker than a battery. So anyway, after a few cycles, you get a charge on them. These relays here kick in, and they bypass those resistors there, and then you got full power going into the power transformer, and hence you'll have full power coming out of it. This relay here in this amp, which most don't have a big relay like that, that's the high voltage transfer relay. This amp has a high voltage tap and a low voltage tap for the high voltage coming out. When you're on SSB, this relay is on one side, and when you go to CW low side, this relay kicks to the other winding of the high voltage, and that's what how you get your high voltage and low voltage, or CW/SSB, on this ham amp here. It takes a nice big relay to switch that 4 kilovolts around, and that's why you see that big wide gap on that relay. That's what you need to play with that 4 kilovolts. Over here you got these 4 devices are the diode bank. That's a bridge configuration, and I said this runs at about 4,000 volts. We're gonna see if we can get a picture in there, and if you can see that, that's a 5,000 volt diode, and all that is basically 5,000 volts. Each of these diodes, similar to this, run about they run 1,000 volts per diode, and this one just has normal single diodes in series. It's got 2 legs of 6. This one was used for a center tap, not a bridge. That's why you see only 2 legs. But this one is a bridge, 4 devices, full wave bridge. And each device, each diode here, has 5 of these internally. That's how that works. It's just, nice and neat in one package, so you don't have to, string them along like that. And they do that in series, which is equivalent to this, to get the voltage up. It's got nothing to do with amps when you're in series. You know, they'll handle the same amount of amps in series, but you know, you're going to have this amp with 4,000 volts. You're going to need, you know, 1, 2, 3, at least, you know, 4 of these wouldn't even be a safety margin. You need 5 of them, you know, so you have a safety margin to run 4,000 volts in it. And that, or you get a single device like this, which has 5 of them in one package. These here are the bleeder resistors, bleed down that power once you turn this thing off. This here is for the B minus. The B minus, instead of grounding the power supply directly, it's got a low value resistor. I believe that one's 10 ohms, looks like brown, black, black. You put that in line in series between the ground and chassis ground, and that leaves a few volts floating around, and with those few volts you run them to the meter, and that's how you get your high voltage and your plate current meters here from, is off that voltage, those few volts coming from there. In the old days, they used to use the metering from the high voltage side of that, and they would have a lot of resistors, you know, in series to drop that high voltage all the way down, because these meters only run on 1 or 2 volts. So in the old days, they would have a whole bunch of power of resistors in series to knock that voltage down, to use it to run your meter, especially the voltage meter. But nowadays, you know, better thinking is to run just a small resistor like this in the negative side of it. That way you don't have to deal with high voltage and all that, you know, and dropping resistors going to the meter like that. Other than that, it's basic stuff with this amp. Vacuum relay there. This is like the watt meter tuning right here. Blower, 88772, door knot, blocking caps. Again, that blocks the DC. The DC comes out of that choke there, and on the hot side going into the tube, and the RF, you know, comes in there too, or out the tube, and only the RF can pass through these blocking caps here. And I use the term AC. Sometimes I use the term AC instead of RF. But anyway, these will block DC. So they'll block that 4,000 volts DC from coming through. But they allow the AC, or the RF, which I guess is a better term, to pass through. And then you got a vacuum variable tune cap. On 10 meters, I keep saying you only need about 4 turns of coil. And that would be the first tap right here. And that looks like about 1, 2, 3, about 4.5 turns of coil. That's all you need, most part, for 10 meters with an amplifier, give or take. And the rest of these coils are for the other ham bands. And this one does have a pi L, like I explained in the other one. It's got a second coil after that first one, which is, you know, tapped, you know, on one of these here. And I believe that's all I wanted to go through today. But anyway, step start, soft start. You're going to have resistors like that in line, and then the relays to shut them off after, you know, a few cycles, half a second at most. And this is something else I was working on. This is just a high voltage board for another project. And, you know, you got your diodes in series to take the voltage. You got your caps in series, again, to take the voltage. And the more you have in series, the more voltage you'll take. You can add or multiply, you know, the 450 volts times 8. And then here's your bleeder resistors and your diode bank. And that's about all it is to this board here. So anyway, oh, I had a guy tell me I need to read a book or an engineering book or something. Well, I've done that. Here is some of the books I dug out my drawer. Just some of the reference books that I keep around. I've read the ARRL books. I used to study that stuff. Here's some more reference books I keep around that I play with if I ever get lost or need anything. But my main book is the Build Or Radio Handbook. If you want to know about amps the ins and out of that. This is my reference, or Lord excuse me, this is my Bible for amplifiers. It's the ARRL, not the ARRL one, forget that. It's the Bill Orr handbook. If you want to know about amps, for me, this is the Bible right here. So you want to have a conversation with me, you know, on my level, read that, and then we can talk maybe. Also, I'm not a PLL expert. I had to go to the books and do some research. I know how PLL works and what they're supposed to do, but I don't have that committed to memory. Most amp stuff I do. But when I work on PLLs, which I don't like doing, I hit my books. The Lou Franklin PLL data book, that gives you a lot of data and references. And then this one here is even more. But then again, kind of once you know what pin is supposed to do what and what a PLL is supposed to do, it's not that hard. It's not easy either. But anyway, I got my books. I've done the research. Been doing it since I was a kid. Read everything I can get my hands on about this stuff. You know, I don't show my station too much, but that's part of it. That one on the left is my audio rack. One in the middle is a Globe King 500, and that's a little amp I'm playing with. That's some of the toys, and like I said, I don't show my stuff too much. I mostly show stuff I'm playing with or other people's stuff. Anyway, I got a little long-winded. I basically just wanted to go through that amplifier thing. So that's it for this one. Bye.